In this video, I'll be evaluating the integral from 0 to infinity of 1 over x squared plus 1 times x to the n plus 1 for arbitrary integer n, or arbitrary. Okay, so what you do is you do the u substitution. U equals 1 over x, implying that x equals 1 over u, or that dx equals negative 1 over u squared du. Okay, and then bring this integral down here. That's equal to the integral from infinity, okay, because 1 over 0 is infinity, to 0 of negative 1 over u squared du, I'll put the du at the end, times, make the substitution, 1 over u squared plus 1, and then 1 over u to the n plus 1 du. Okay, which is equal to, flip those two around, get rid of that negative out there. So I have 0 to infinity of 1 over, that u squared goes into there. I'll distribute it in there so that I have 1 plus u squared times 1 over u to the n plus 1 du. Multiply both the top and the bottom by u to the n, so that I get the integral from 0 to infinity. So multiply top and bottom by u to the n. So this is equal to the integral from 0 to infinity. I'm going to rewrite this in terms of, x. Okay, so x is now my variable. X to the n over x squared plus 1 times x to the n plus 1 dx. And so, right there, if I call this I, that means that 2i is equal to this integral plus this integral, which is the integral from 0 to infinity of, and then we're going to have x to the n plus 1 dx over x to the n plus 1, x squared plus 1. Those cancel each other out. I get the integral from 0 to infinity of dx over x squared plus 1. And that is simply going to be tangent inverse of x evaluated from 0 to infinity, which is actually going to be pi over 2. We have a 2 out there, implying that I is equal to pi over 4. And this is for arbitrary n. None of this had anything to do with a specific n. Okay? So this I right here is pi over 4. Or in other words, I'll write it here. Integral from 0 to infinity of 1 over x to the n plus 1 x squared plus 1 dx equals pi over 4 for any n, an element of the real numbers. And we're done.